Hello everyone, in our last video we created an intricate ornament pattern. Today we will take it a step further and integrate it into our fabric design, creating a rich and organic textile effect. Let's dive in by creating a new substance graph and selecting metallic roughness as the template, and give it a name, and click OK. To start, we need a base fabric texture that mimics the natural weave of fabric. Add a Weave 2 node and set the scale to 64. Duplicate this node by pressing Ctrl-D and double-click to preview it. To introduce some variation, apply a disorder of 0.05 and enable Rotate 45 degrees. Blend both nodes using a blend node with the Max Lighten mode. This creates a crisscross pattern that better simulates a woven fabric. While this pattern looks good, it is still too uniform. Let's introduce some natural variations by adding a multi-directional warp node. This node requires an intensity input, so we will use a noise texture. Insert a Gaussian noise node, scale it to 300, and connect it to the intensity input of the warp node. Reduce the intensity to 1.5 and change the warp mode to max for a more organic look. I think the noise is too much. Let's reduce it to 250. Now, let's make this pattern more fabric-like by adding a Transform 2D node and using the Divide by 2 option twice to reduce the pattern's size. To add color, use 2 uniform color nodes. Blend them together using the fabric pattern as a mask. Set a darker shade for the background and a lighter shade for the foreground to enhance depth. For this tutorial, we are using a magenta color scheme. You can follow along using the color codes displayed on the screen. With the base fabric ready, let's overlay our ornament pattern. Import the ornament design and invert it to ensure that Substance Designer correctly interprets black as the background and white as the foreground. Add a bevel node to smooth the edges, setting the distance to -0.003 and smoothing to 0.75. Use a Tile Sampler Grayscale node to distribute the pattern. Add a Uniform Color node, change its color mode to Grayscale and Color to Gray, and connect it to the pattern input. Set X and Y amount to 800, change the pattern mode from Square to Pattern Input, adjust size Y to 0.66, and scale to 4. Connect the normal output of the bevel node to the vector map input, and the height output to the rotation map input, and connect the inverted node to the mask map input. Fine-tune the distribution by setting Position Random to 0.2, Rotation Map Multiplier to 0.2, and Vector Map Multiplier to 0.6. These adjustments help break the uniformity and add a more natural variation to the pattern. Now, change the Mask Map threshold to 1 to refine the edges, ensuring a clean, well-defined ornament. To introduce some subtle variation, increase the color random value to 0.3, which will add a bit of randomness to the colors. Now that our ornament mask is ready, let's move on to applying color. First, add a Safe Transform node and tile it 4 times to ensure proper distribution. Next, blend 2 uniform color nodes to create the ornament's color. Connect the Safe Transform node to the opacity input of the blend node so that the mask properly controls where the color is applied. For this design, we'll use a golden color, but feel free to experiment with different shades to achieve the desired look. By adjusting these parameters carefully, you can create a visually appealing ornament that integrates seamlessly into the fabric. Now, let's merge both elements. Use a blend node and connect the base fabric to the background input and the ornament design to the foreground input. To properly mask the ornament, connect the Safe Transform node to the opacity input. Preview the result by connecting it to the base color input in the 3D view. Now, let's add decorative borders to our design, starting with the top border. Begin by adding a Tile Generator node and setting the X and Y amount to 1. Change the pattern to Square and adjust its shape by switching to Normal Size mode, setting the size Y to 0.2. To ensure proper positioning, use a Transform 2D node and set the Horizontal Tiling mode. Now, scale and position it accordingly. Then, add another transform 2D node and adjust the Y offset to 0.48 to align the shape correctly. Since we don't need the lower portion, change the tiling mode to horizontal for this as well. Finally, blend these two shapes together using the Add Linear Dodge blending mode to achieve this effect. You can reposition the shape by selecting the Transform 2D node and adjusting its placement until you achieve the desired result. Next, we will add color to the border. Since we only need the white part, introduce a blend node and connect this shape to its opacity input. Use a uniform color node for the foreground input and assign it a dark green color. Notice how the white area has changed color while the black part has disappeared. This is because there is no background input in the blend node. To properly integrate our fabric design, simply connect it to the background input to unify all the elements seamlessly, ensuring a cohesive and polished final look. For the bottom border, we will use a separate bitmap. Here I have already imported the bitmap I will be using for the border and changed its color mode to grayscale. Now, connect a Transform 2D node to scale it down a little bit. Carefully position it at the bottom, ensuring alignment with the overall design. To prevent unnecessary tiling, modify the tiling mode to horizontal tiling. Next, introduce a tile generator node, setting X and Y amount to 1 and selecting square as the pattern. Adjust the size mode to normal size and set size Y to 0.2 for a well-proportioned look. Now, use a Transform 2D node to correctly position it at the bottom of the design. To integrate the border seamlessly, blend the shape with the border design using the Add Linear Dodge blending mode. Place the border design in the opacity input and this shape in the foreground input to achieve a layered effect. To apply color, use two uniform color nodes and blend them together, using the border shape as an opacity mask. The color codes are displayed on the screen, allowing you to follow along by copying and integrating them into your design. If you notice any unwanted areas or color spill, introduce another blend node and use this node as a mask to remove excess elements. Finally, merge the bottom border with the top border and the fabric design. This ensures a cohesive and balanced look, seamlessly integrating all elements of the pattern while maintaining a visually appealing finish. To enhance realism, convert this node to grayscale by adding a grayscale conversion node and connect it to the normal maps and adjust the normal intensity as needed. Let's add 0.1 for now. We can always change the settings later. For a shiny silk look, set the roughness node value to 0.35 and increase the metallic value to 0.95. And that's it. Our fabric is now complete. This design is specifically crafted for an Indian traditional outfit known as a sari, but you can easily customize it to suit other fabrics and styles. Experiment with different patterns and colors to achieve unique results. Thanks for watching. Don't forget to like, share and subscribe for more Substance Designer tutorials. See you in the next one.